So now that we have our simple storm drain system in, we can use this model to review the results. I'm going to start by going to the Flow2D documentation. Yours won't have the one there, by the way. Flow Help, Handouts, and grab this reviewer's checklist. This reviewer's checklist has a storm drain tab that has some really simple checks, about 18 of them. Most of them are really easy, but of course, the larger storm drain system you have, the longer this will take. But typically, we are going to go through each of these checks kind of carefully just to make sure that they are, you know, compliant. And then before we do that, we want to make sure that like all of our data is ready to go and ready to review. So one thing we can do if you're using Flow2D plugin Gila 2.0, Robson put in this little quick uh, file picker, which is going to set your results folder. So that'll be right here. Select that folder. And then when you have that folder selected, you can use the results tool to grab results for these different features: channels, conduits, storm drain, inlets, outfalls. All of these different features are now assigned or can now be plotted for results. So we also have that, and I don't recommend using this if your project is really large. If your project is really large, I recommend using the flood control districts tool. It's called I guess it's called a post-processing tool or a pre-processing tool. I don't know, whatever it is, it does all of this for you. But you can do this tool too, where if you have a small project and you can check all available maps and click create maps. It's not actually going to be creating maps, it's going to be creating plots. And once you do that, you can see that you have your plots right here. Graphics. Yeah, I don't think that one had anything, right? Links, flow, and then you can see these will be all the flow through these links. It'll also have depth, percent full, and velocity. So you can check all those. And you also might want to add, like I ran this model with a depth map. So I can plot the mesh. And so I load the mesh right here. I just point the mesh tool to the depth.out file, and that will load my and click add, and then that will load my depth map. Also, so that kind of gets you ready to, and then also, of course, you want your project folder open. So you want this to be open and set to where all of your .out files are. So we've got our .dat files here. We've got our .out files here. All of our storm drain files are in there and our check files. And then I start opening some of those up as we go. I just start opening some of those up using Notepad++, okay, so we'll just leave those open for now. We'll leave those alone. And you don't have to open them all like that. I kind of open them as I go. And the first thing we'll start to do is go to our checklist, and it says that verify the order of the structures as they appear in the swimflow.dat. Make sure that that order in swimflow.dat matches the order in SwimINP. Now, if you're using the Flow2D plugin, they're going to match because we order those alphabetically. Also, make sure that your inlets have a capital I. Now, I think it's no longer a lowercase I is accepted in build 23. That was a bit of a bug, but so I do believe you have to use a capital I. Okay, so I'm not going to check that, but bottom line is you got your swimflow.dat here, your SwimINP here, and you just make sure that these are in order and they match. But because I use the Flow2D plugin, I know they're in order and that they match. Okay, back here, we've got verify the input data conflict tool does not report any conflicts. So if you're with the flood control district, you're probably using the post-processor program. I don't know, post-processor. It kind of depends on who you are, what you call that. But you're probably running that tool and it's giving you a conflict map. But with QGIS, you can do a current conflict list. Now, take in mind that I haven't finished my walls, my buildings, or my hydraulic structures. So our conflict list is a little boring right now. But if I go to warnings and errors, I can do current project and I can click OK, and that will run the conflict checker. And all of these conflicts, inflow on a channel left bank, that's fine, that's a channel. Outflow on a channel left bank, that's fine, we did that on purpose. 2 or more channel in a right bank in the same cell, as long as it's not 3 or 4 or something like that, it should be okay. I would say don't go above 2 or 3 to share a right bank, and then the same one right there. But because I'm missing a bunch of other features, we're not getting a ton of conflicts. Don't worry about this. I think it's because this shapefile was already created and in here. That's why we're getting this error message. So don't worry about that error message. You probably won't see that. All right, let's go back here. So our conflicts are good. Verify the model does not include any short pipes. Okay, so with Flow2D, our conduits, we come here to our conduits and right click, open attribute table, and then we want to find conduit length and sort that by length. And anything that's less than the grid cell size, you just want to reset to the grid cell size. So it's very easy. You'll just select the ones that are less than the grid cell size, hit edit, change this to conduit length, and set that to the grid cell size, and then update selected. I've already done that, so I'm just going to deselect all and turn that editor off and go on to the next one. Verify the outfall location is correct and check the invert elevation and check for adverse slopes. So at this point, you can take every storm drain network in your system and check the profile of every storm drain network in your system. You can do that using EPA Swim GUI, PC Swim, or you can do it using our tool, which is right here. So for example, if I'm going to click a node, I'm going to go to this button right here, and I'm going to click this, and I'm going to go to my inlet junction, and I'm going to set that as the start node, and I'm going to set my outfall as my end node. And then I'll click plot profile, and you'll be able to see the profile. In this case, the profile also includes the results, but what am I looking for? I'm looking for inverted pipes, or I'm looking for bad elevations, or possibly bad um, node depths, right? Rim elevations. So any of those things you can quickly check with any plotting tool. And then kind of depending on the software that you're comfortable and confident with, you can use any of the software to view storm drain profiles. All right, let's go ahead and do, let's see, let's go ahead and do back to the list. Now, so on the outfall, the location is correct. Check the invert elevations and check for adverse slopes. Okay, so that will be, zoom in here. If you're on this tool, you're going to check your outfall attributes. This will give you your invert elevation. And in this case, we want that to match our channel, but sometimes they're a bubble up. So sometimes that will be lower than your channel invert if it's a bubble up. And now if it's a bubble up and it's lower than your channel invert, try setting this switch to allow discharge, but ignore the underground depth. And then that outfall type could be free or normal or fixed, and that would be the correct application for that. In this case, there is no flap gate, so that goes to no. And correct position, it needs to be assigned to the left bank, and it needs to be away from other features. All right, next. View the option to allow outfall discharge to be returned to the surface. So that's a very simple check. It's easier to check that through this file, swimoutf, because all of your outfalls will be listed here. And you just want to make sure that this switch is set to 0, 1, or 2 correctly. Okay. And if it's not, you can go in here. Well, if it's not, you can select the name right here, and you can go back to your editor and let's just close this guy, put your object right here, click that, and it will load that for you so you can modify and fix that. Next is verify the rating tables start with 0. So the easiest way to do that is to select your first rating table and then cycle down through them, and you're just making sure that it's a valid looking rating table and it starts with 0. That's an easy check. The next one is to, if you're using SD clogging, you need to I guess you need to get with the district so that they know that you're using it and they're using it correctly, because typically they will include the clogging in the development of rating tables and things like that. So make sure that you get with them, because usually, like, if they rather than using clogging, they might like change the dimensions of the inlet or something. So that's just something to consider. Uh, so SWIM INP, if the QGIS plugin is used to develop the input data, the parameters at the top of the INP file under options will be set by the program, so you can just accept them. Also, this routing step is something, the routing step and lengthening step are default to Flow2D. The plugin and the flow routing is default to FlowPro, to the Flow2D storm drain engine will default some of those. But one thing you do need to check for is that your flow units are set correctly, because in Flow2D we only use CFS or CMS. So if you go Control Home on the INP file, you don't want this to be gallons per minute or something silly like that Flow2D doesn't use. So it'll be either cubic feet per second or cubic meters per second, and this will be determined by your map units in the Flow2D plugin. So if your map units are set to US feet, then this will be set correctly. Next, SWIM INI, super easy check. Well, let's just go here. In the SWIM INI file, you just want to make sure that these two say that they equal to. And SWIM INI can get relatively complex, but for Flow2D, you really only need this. But it can get more complex because this is what controls the EPA SWIM GUI and how it plots data. But we only need this for Flow2D. So if you have more stuff in there, that's perfectly fine, as long as you know what it's doing. Here we go. Verify that the inlets and outfalls into a channel are assigned to the left banks, not interior and not right banks, because we're assigning it to the cross-section, and the cross-section is always cross-referenced to the left bank. So any inlet or outfall, if you're assigning it to a channel, make sure it's on the left bank. Now, there's another instance of this that might be a little bit different. So be careful if you have a inlet that's along the bank, make sure it's not assigned to a right bank, because you might have accidentally assigned it to a channel. Sometimes I've seen in projects that because of the grids, due to the grid resolution, I've seen that the manhole is accidentally assigned to the left bank when it really needed to be off the left bank. So once you've assigned something to the left bank, that automatically assigns it to that cross section. So be careful both that they are correctly assigned and not inadvertently assigned to the left bank. Okay? Verify the elevation of the SWIM inlet outfall against the channel invert to make sure that they are configured correctly. In most cases, the outfall elevation or inlet elevation should match the Thalweg, but it doesn't have to. Sometimes it can be a little bit higher. Sometimes it can be a little bit lower. Sometimes those inlet or those outfalls sort of pour into the channel, so they're perched, and sometimes they bubble up into the channel, so they are underground and they are bubble ups. Okay, so they don't have to be the same, but you need to make sure that they are correctly configured. How do you do that? You come here and you check your channel. Let's do this. We're going to get, we want this one right here. We're going to get the, well, sorry, I unchecked. It's a toggle. I untoggled it. We're going to get our channel, which is 1398.06 is our invert of our channel. And we're going to check our storm drain outfall. And in this case, hang on a second. Sorry about that. I'm not sure why that didn't see attributes. I'm not sure why that didn't. Oh, I think it's because we already have it in here. Yeah, sorry. So this one is 1398.06. So it's exactly the same because I already changed it in a previous video. But you can see right here that originally the grid, this is our channel elevation and this was our storm drain elevation. We know that's not true. I mean, you can see that in this case, I think this one is not a bubble up. So you can see it coming down in right here. But like, I believe in this particular channel that this one over here, that ones that coming in over here are bubble ups. Some of them, one of them is a bubble up and one of them is not a bubble up. So this one's a little different. So be careful about that. You set those and configure those correctly. Next, storm drain error.check. So we're going to check all the warnings and errors in the storm drain error.check and the error.check, may as well while you're in there. So here's your error.check. No, nothing related to the storm drain and no errors, because this is not an error. It's just a note telling you about how the channel exchange will work. Storm drain error.check does have some notes and some errors. So it does say that the weir coefficient is outside the typical range. So the way that you would fix that is you would select that inlet name, come to here. We can close this one. Let's see, put that in there. And we can modify that. See, it was a weir coefficient. It was out of range. I think it was originally 2.3, and I just bumped it up to 2.8 to get it within the range, or set it to what you think it should be for a valid weir, weir coefficient for flow over the edge of a grate. That's what we're trying to do with that. Okay. Next is you want to make sure that your storm drain engine and your Flow2D Pro engine, you want to make sure that the builds match. So check these two messages. And the storm drain outfall invert elevation should be equal or greater to the channel, street, or grid elevation. And in this case, we already checked that and we already made that correction. Note there are differences between the grid and storm drain rim elevations. So, and then of course, if there's a type 4, it's going to plot that difference right here. And it says, note, manhole covers were removed. Please review that file. Okay, so we are going to, first, we're going to look at this one, and I'm going to copy this. No, sorry. Well, we can do it either with a grid element, or you can do it with a node name, your choice. Either way works fine. So let's do it here, and then we paste that there, zoom to that grid element. And what I did here is I used this tool here, and we know that that grid element elevation is 1418.8, and we know that the this is a type 4, so we don't use the rim elevation to do the grid elevation correction. We use the invert elevation. Now look at this here. Sorry, this one is 1426 and this one is 1418 because I already made the correction. So I wrapped a polygon around that centroid of that grid element, and on that polygon, I gave that a storm drain head wall. I set the elevation to the correct rim elevation of the invert, and I set the membership equal to grid. And then I came to the Flow2D editor, grid tools, and I performed the correction, and I did it only on the selected polygons, because you're going to do that for hydraulic structures too. And so that one uses the grid elevation to correct that. Now, why did I move it one away from that? Well, you can either correct this elevation, or you can move it slightly out more into the basin and correct this elevation. It doesn't really matter. It's close enough. As you can see, it's only a 30 by 30 grid. So you can do it either way. And it kind of is, maybe that is your reviewing agency will tell you to move that. Maybe they'll let it go. I don't think that it really matters. One of the another problems in here is that we do get flow into our basin, but I didn't put this hydraulic structure in yet. So this culvert between those two basins. So we're not getting a lot of flow into this second basin. Everything is contained up here. Let's see, where are we now? We are, back here. Oh, by the way, right. So this is checking the rim elevation. Sorry, there's one more file. It's called fprim elevation.out. So you might want to check and correct these. If you're working with the flood control district, you're going to want to correct all of these. But basically what Flow2D does when Flow2D runs is it uses the rim elevation of your feature Okay, so it's going to default to the rim elevation of your feature and is going to change the grid elevation to the rim elevation. So you can, but the district wants you to correct these. But just so you know, Flow2D is already doing it. But of course, if any of these are way off, that's a red flag that you want to check and fix, okay? Next is check the storm drain volume exchange section of summary.out and swim RPT. So what I've done is I've loaded, let's see, summary.out here. Let's put a summary.out over here and we'll do our swim RPT here. And what we're looking for is continuity. So continuity, right? And then over here, we're looking for continuity. Okay, so it says 0.026, and then we want to just make sure that those two numbers are the same. And then if this gets above 1%, the flood control districts want you to try and fix the storm drain continuity error. Now, typically speaking, you'll see right here that there's two nodes that are causing our continuity errors, and it's probably related to this one is that possibly that I3 that maybe had that wrong weir coefficient, and this is probably that popped manhole. Oh, which I was supposed to open that manhole popping file because I missed that last storm drainer. Sorry, manhole covers were removed, review that file. So let's go grab that file real quick. Manhole covers, I think it's popped. Oh, there we go. Yeah, that's it. And it'll tell you which one of these were popped. And let's see. This will be X coordinate, Y coordinate, grid elevation number, feature name. I think this is the time that it popped. And then this would be like the three pressures. Just check the data or check the storm drain guidelines to see what these variables are. But one would be like the pressure head, the water surface elevation, and the difference between the two or something like that. So you can see that our pressure head exceeded our, so this would probably the grid elevation, and this would be like the total pressure on that particular manhole. So easiest way to get to those is to check them like this. And if you don't think that that manhole actually popped, you don't think that that's really not valid for that to have popped, then you can make some modifications to the system. Like, for example, I definitely know I want that hydraulic structure in there to reduce the flooding in this area because I'm probably getting too much pressure. There is a lot of pressure coming in from here. There's also a whole nother system coming in right here that we haven't even modeled, because this is the simplified system. And so that's one you want to check. Let's go ahead and grab the other one. So in that case, I'd put that hydraulic structure in. Let's see where this one is. Okay, same area. So that hydraulic structure might sort that out. Also, if you're still getting popping in here after you've put that hydraulic structure in, then you might want to consider like maybe giving this conduit slightly higher N values. That usually what fixes popped manholes is giving those conduits slightly higher N value. If you don't think they're going to pop. If you think they could pop, then possibly it's possible that that is realistic. And here's one more. Let's see about this one. Let's see where this one is. And same thing right here. So like, for example, if that manhole cover maybe you don't expect it to pop because it's locked or bolted or something, you could change the behavior of that manhole cover. But there's probably a lot of pressure on this system right here. Let's take a quick look at the flow in that system, at that manhole. So yeah, total flow passing it is 300. Let's take a look at the capacity. Let's see, percent full. Yeah, see, that's getting up to 100% full in here. So probably what's happening is that me not putting that hydraulic structure in is causing a lot more pressure in here than this should be getting because a lot of this flow in here, a lot of this flow coming from here should probably be going through this culvert right here. And we might maybe shouldn't be getting so much depth up here because it should be coming down here through that culvert. So that's the first thing I would check on those. So it looks like all of 3 of the popped manholes are inside this basin, which this basin, because this flow from this creek comes down through here, this basin gets a lot of water right into the storm drain system through this huge grate right here. So it probably does get a lot of pressure from that flow going in there. So that's probably not surprising that those are popping off. But if you don't think they should be popping off, then maybe put that culvert in, check a little bit of the connectivities in there, make sure that, like maybe bump those end values in those underground, or those ones that are under the basin, make sure those end values are a little bit higher for those for those conduits through there. Okay, what's next? Okay. Now, this says to perform spot checks, but it's just as easy to review all of the hydraulics of every system. And what am I looking for? So here's when I first turned this on, I showed you how to make those storm drain plots. And if you're going to go into your storm drain plots, you can see that we have this MapCrafter folder, and it has the storm drain, and it has links. And here is the flow through every link. And so as you can see, the flow through every single link. What am I looking for? Well, this one's going backward. This one has a negative flow, so I want to check on that one. This one looks a little suspicious because, well, it has that negative flow, which is not suspicious to me. That's probably from the channel. And that one seems okay. So that I'm not too worried about that one. Uh, well, let's take a look at one of them down here. We know this one right here is suspicious. So I might take a look at this one and see why is this flow doing this. So let's do this. Let's just take the first part of that name and we'll put that in let's go ahead and shut this one down, and we'll shut this one down, and we will go back to our storm drain editor and put that in here. And what happens right here is that the PJ? No, because that's supposed to be an A. Let's take a quick look at the results of this one. Let's say show results. Okay, so here's our results and here is our feature. And what's happening is that this is going from 0.75 to 0.85 right here. And so possibly what we want to do is maybe give it a slightly higher end value. It started at 0.013, so I might bump that up to 0.015, or I might try like an entry or exit loss coefficient between these two different diameters at this manhole. But I might give this one also, maybe give this one a slightly different, let's see if we can grab that velocity. Yeah, might give this one and this one a slightly higher end value, because it's these two right here that are causing the problem. But I don't think the manhole is popping off, but I do think that the conduit is full. So let's see if we get the percent full. No, that didn't actually, the conduit isn't completely full. That's interesting. Yeah, let's check percent full. No, it's not completely full. So it's just that change in capacity right there that's causing that surging. And it could be valid surging. It could be valid that that's surging right there. So it's something to consider, that not all surging in these conduits is, some of it is natural. And some of it you don't want to try and fix. So 2 things to think about. 1, go ahead and give it a mildly larger end value, 0.013 to 0.015. And if that doesn't really change anything or fix anything, then it's probably valid surging. Okay, what's next? Verify continuity errors. Yeah, we already verified that. We already showed you how to check for those. For the manhole pop-off, perform a spot check. Yeah, we just did that. Now you're going to make sure that the rim elevation, surcharge elevation, and pressure head match the storm drain HDL you can use the EPA swim GUI, or you can use the Flow2D plugin to do that. And also If you have popped off manholes that you don't think that those should be popping, again, make some mild adjustments to those end values, bump those up a little tiny bit in those conduits associated with those manholes, because sometimes you'll get like this really strong pressure, like right at the start of a simulation. So if you know when those popped off, that's important. If they're popping off like at, I think this is the time. So if those are popping off at like zero 0.1 hours, you know that that's not valid, right? So minor adjustments to the end values of your conduits will prevent those from popping off where they're not supposed to be popping off. Output file reports the differences in elevation in the rim. Yeah, we already talked about that. We already showed you how to do that. So you're going to verify the and modify the FP rim elevation dot out. I think the district wants you to validate this, and they also want you to make sure that that file is basically empty when you report it to them. So you're going to like show that you fixed this. Swim QN, spot checks in the Swim QN, Swim RPT. Again, the district program and our program will both create these graphics, these plots, so you can check this stuff. And again, what am I looking for? I am looking for unstable, instabilities, surging. It could be numerical surging, or it could be like, valid surging. I'm looking for high and dry nodes. So if a node doesn't have any discharge, why does it not have any discharge? What else are we looking for? Backwater conditions, like do we have any flooding? So for example, there should be one in here that is flooding. And so if you see one of these that shows flood, that this one is flooding, then that's one that you want to check. So 41236, we'll do that. 41236. And I'm fairly certain that's in our basin. And we know that we have a lot of water going into this system. So I do anticipate this one to have flooding. And then if you can check on that, you can do this right here. You can see results, and you can see that it does have return discharge to Flow2D. So all of this discharge right now is returning to Flow2D, and then when the water gets deeper in this basin, then it starts moving the other direction. So that's how that works. That's how that one right there works. Okay. What else do we got here? I think that's it. So that's basically a kind of a quick and easy storm drain review. I don't want to get into too much more detail than that. I think this is appropriate length of this video. So if you have any issues with the storm drain modeling, of course, tech support is part of your Flow2D support package. You purchased that when you purchased the software. So let us know if you have any issues with your storm drain, and we can help you fix those.